We'll give it just another minute or two and then get started. If you could, in the chat box or questions, just let me know if you can't hear me. Well, if I'm not coming through very clearly or whatnot. That'd be helpful. Thank you. Okay, I'm going to go ahead and get started. My name is Louis Mino. I'm with TEC. Today's presentation is on radiant estimating and installation. This presentation is not for PDH credits, so we will not have any poll questions or whatnot. If you do have any questions during the presentation, please feel free to enter them in the chat or question box, and I will try and pause a couple different times to address those. I'm trying to keep this as informal as possible, so if you do have questions as we go along, I will try and answer them, but at the same time, I know you guys are all trying to get out of here at a reasonable amount of time, so I will try and keep it quick pace at the same time. So let's get started here. So I'm going to be jumping through a couple different presentations to make sure that we're covering as much info as possible, but this is our general overview. I'm going to go over a few expectations for radiant systems. We'll go on to the general installation techniques, tools for estimating materials, and then some general rule of thumbs. One thing we're not going to cover here is anything regarding load calculations. I will give you some rules of thumb, as I said, and we will talk about what kind of load you can expect to get out of the system, but the heat calc will obviously be completely dependent on the building design and the layout of, walls, windows, etc. So nothing I can possibly address here in that regards. The first thing to really analyze when you're looking at a radiant system, or someone tells you that they want a radiant system or they want warm floors or whatnot, is to examine the feasibility of the installation. And my first note here has to do with the heat source, and I want to just clarify, obviously radiant can be used for cooling as well, and snow melts. The installation techniques that we're discussing here will apply to all those, but in terms of the feasibility and some of the techniques, we're going to be specifically looking at mostly radiant heating today. Like I said, a lot of it applies to all, but specifically radiant heating, and I'll try and point that out where appropriate. But in terms of feasibility, you need to make sure you're going to have some sort of heat source. So whether it's a boiler or a geothermal loop or it's coming from somewhere else, if someone wants to install radiant heat, they're either going to have one of those existing or you're going to have to add one of those to the system. Depending on where the zone is located or the project is located, supply and return piping accommodations. We're going to discuss different installation options, but you have to make sure that there's some way to install the radiant in the zone that they're looking for, use of the space, and the output required, and then the cost of the system. Radiant systems in general are inherently upfront cost weighted, meaning most of your cost is going to be the initial install. After that, they're extremely efficient. So it's all about setting expectations with the customer, of course, but these are definitely some things you need to keep in mind as you start approaching a radiant system. So in terms of expectations, obviously radiant is prized for its comfort applications. It creates a great temperature gradient from floor to ceiling, so everyone is more comfortable. But at the same time, there are limited outputs for it. It does feel slightly different than a traditional heating and cooling air system. So it's all things that you need to cover with the customer when they initially come to you for this option. One thing to note specifically, though, is what type of flooring they would like over the radiant system. The floor covering has a lot to do with the amount of heat that can be extracted from a radiant system, and along with the amount of insulation that's put on the other side, you still have to drive that heat up into the space. So if you're using a natural hardwood or carpet or cork, these materials are more insulative, especially, or carpet, vinyl. So you have to be a little more careful with those. I'm sorry, vinyl should not be in that group. Carpet is definitely a bigger insulator. If you're going with vinyl or tile or marble, those are traditionally much better radiant materials because they allow heat to pass through them and they can hold heat over time. A lot of engineered hardwoods are lower than a traditional hardwood or laminates and whatnot. So those can work well in the right situations. Whenever you're using an engineered or solid hardwood flooring, you want to confirm with the manufacturer's recommendations on or confer with the manufacturer to see if there are any limitations on temperature. Your surface temperature on a radiant system is only going to be about 80-85 degrees, but that's something that definitely needs to be taken into consideration if they're using a specialty wood, especially in higher end homes. It's very common. All right, as far as what load you can expect to extract from a slab, it all has to do with the amount of the temperature gradient between the space, the water that's supplying it, and then the surface temperature that you're accommodating. So as I just mentioned, in space heating, our typical surface temperature is a max of 85 degrees, I believe, but that's regulated by ASHRAE. It's by code so that the surface temperature is not objectionable to the patrons. So using standard room temperature, the most you can really extract from a standard concrete floor with a minimal floor covering is around 40 BTUs per square foot. Now that varies. It can get up a little higher or lower, but it's a good estimate for what you can expect to extract from a space. So if you ever need to do, if a customer's looking to offset some of their heating load, some of these numbers are a good place to start. If you're applying the heating from beneath, I'm calling it underfloor here, but like in a joist space heating system, where you're attaching the flooring to the tubing to the bottom of the floor, that number drops to around 20 BTUs per square foot because you have to drive the heat up through the subfloor. This isn't really regarding performance, but these next two are common load profiles for similar systems. In a floor warming situation where the customer is just looking for warm like tile flooring in a bathroom or in a kitchen, you don't necessarily want to size it for a full output load, and that can, in that situation, be looking at a 15 to 20 BTU per square foot load. And then snow melt can go as high as you want it to, really, but we recommend typically around 125 BTUs per square foot for this region. There's all sorts of specialties applications that can be applied to this. In those situations, you really want to get involved with the manufacturer so that they can help you identify any particular problems with those installations or anything you need to look out for. Okay. Oops, went too far here. As I mentioned, going back to the heating source or cooling source, if you're going to be using a high temperature source, you need to make sure that you're examining a mixing station or from the manufacturer, or well, you can design your own, of course. Most manufacturers, though, if you look at this one on the left, this is a mixing station that bolts onto the manifold and can handle that locally at the manifold. Otherwise, if you have multiple manifolds, you'll need something either for each manifold or one upstream of all of them at the boiler. If you're using a cast iron boiler, it's very important that you use a four-way mixing system that is evaluating the temperature going back to the boiler, so that the mixing temperature is not only appropriate for the floor, but also so that the cast iron is not seeing a low temperature that it's not expecting. As well, if you're doing low temp heating, geothermal and condensing boilers are obviously an ideal match for any radiant system. They work very well. They're already delivering the low temperatures that you want anyway, extremely efficiently. Cooling, there are certain considerations due to dew point and whatnot that I'm not going to address too much here because that's its own topic, as it can get very specialized. But cooling is installed the same way, and again, the same considerations. You're going to need a chiller or a geothermal loop to supply that, and you're going to have to plan accordingly. And there's certain specialty applications, using heat reclaim on chillers, or using a side arm on a domestic if it's a really small zone, or wood-fired boilers. Those are all applications. Anything you can warm or cool water with can be applied here, but you just need to make sure you're taking the appropriate steps to protect the slab from extreme temperatures and protect the heat source. All right, we're going to jump into the radiant install portion here. Let me quickly switch over. Real quick, I did get one question come through. In the carpet applications, the pad also makes a difference. Yes, absolutely. The pad would certainly add to the insulation value. We're going to be showing, I think in coming up, I have a little slide showing a cross section of it. But yeah, anything that you're putting on top of the radiant or between the radiant and the space is going to certainly increase the insulation and then decrease your output. So it's something to definitely consider. I don't see carpet over radiant very often, unless it was like a throw rug or whatnot. But that would, carpet definitely puts a big damper on your output. So that's something to be cognizant of as well. Going forward with the install here. So as I mentioned, the feasibility is the biggest thing, but then you have to decide what type of installation is appropriate for your area. So we're going to be looking at several different techniques. They mainly break down into, the easiest way to break them down is into wet installations and dry installations. And wet installations will be any installation that is using a poured thermal mass, whether it be concrete or gypcrete or some other lightweight concrete type material. And dry installation would be either installed in the duct or over a subfloor or an existing slab where concrete is not going to be applied. All right. As I said, we're first going to touch base on the wet radiant installations, and as I said, that is anything with a poured thermal mass. It's typically concrete, Portland cement, but definitely different materials are becoming available and to make it easier to pour, of course. So that will affect how the radiant's installed. Typically with a wet installation, there's two main installations, a structural concrete slab and then a suspended like wood floor or other deck that has the material over poured. And as you can see here, they're kind of showing it both ways. On the left is your standard poured slab, and on the right is a over pour installation in a residence. In terms of the structural integrity of the slab, here they're specifically talking about structural fibers in concrete, but in any case where you're using a specific concrete product, you want to check with the manufacturer that, or more aptly the structural engineer on the project, to make sure that they're okay with the tubing being in the slab. Almost anything they can put in a slab will not affect the tube itself. You always check with the manufacturer, but most of them will tell you the concrete will never bother the slab. Just in some cases, you need to make sure that the structural engineer is accounting for it. Now, tubing takes up such a small cross-section of structural slabs. I've never had an engineer come back and tell us that it was going to, hinder the performance of the slab. But especially in commercial large applications, that is something you definitely want to run by the engineer and make sure they're accounting for it. In a residential slab on grade or an overpour with a concrete or on a wood subfloor, it will not be an issue with the spacing and pipe sizing that you're going to be using. Yeah, and so specifically here, they're talking about the fibers. Again, these will not hurt Rao, which I can speak on, but I would check with other manufacturers. They should not have they should have the same policy. So here's your typical breakdown. If you're looking at this bottom portion here, the 4 to 6 inch concrete is on the top. The tube is being secured to the blue that they're showing here, which is representing insulation. And so whenever you can, putting insulation beneath the slab is highly recommended to drive heat upwards. It can be a foam underlayment, or it can be like a very common would be like an air-filled or bubble wrap type insulation that has a radiant barrier. Both of those are acceptable. The engineer in certain situations might specify one or the other at their discretion, and that's certainly up to them. We've used both in different situations and both work very well. Edge insulation, which we might touch on here in a second, is commonly required by code depending on how it's being installed, or I'm sorry, depending on the application. Most residences will require there to be some edge insulation, but that's something that you want to double check with either the general contractor or the engineer and the local jurisdictions. If you ever have questions about those, feel free to contact me or anyone in our office, and we can help you find the appropriate code for those. So this is just another typical cutaway, breaking down what we're going to be looking at here. The top part, again, the slab, and then this is just showing the pipe better secured. Again, we want to be driving the heat up into the space and away from the subgrade or the zone below. So any insulation Again, this is in a concrete slab, so it's obviously going to be tucked underneath the slab, but as we'll see in other installation types, it can be applied in different ways. Edge insulation, as I mentioned. So I'm kind of going through these a little faster just because of the time, but if you need me to slow down or anything, please just send in a note or whatnot. All right, I'm going to quickly go through some of the different fastening techniques for these wet installations. This is obviously the most typical, is putting nylon ties connected to wire mesh. In a concrete slab, this is 95% of the installation technique that we see. It's very crude and it's simple and it works very well. It is very time consuming and it hurts your back after you've done a couple hours of it. Because you are going to be putting them every 2 to 3 feet. They're showing them very close here for the example, but you do need to tie them down every 2 to 3 feet, and in a bend like this you may need to add a couple more. They're very strong ties, so they're made for this application. You do want to be careful with the tails stick. You want to make sure the tails are all pointing down, or snip them off and make sure to throw them away so they don't end up floating and getting stuck in the top of your slab there. The other option we see, the second most, I guess you would say, would be using foam staples. If you're using foam as your insulation anyway, this is a very quick technique for installation. Saves your back a lot if you have the upright gun, as they're showing here on the right here. But basically it's just using a Talons type staple that goes into the foam board versus using a tying it to wire mesh, and then the concrete is just poured over the top. It's definitely a great option. Again, you're paying for the talons and the gun and whatnot, so it's a little more upfront cost than just using the nylon ties. But if you are installing these more regularly, it's definitely a great low-cost installation tool to really speed up your time. Here's an example of it installed. One other option we don't see a lot, but it has its applications, is what Rao calls Railfix. Most of the manufacturers have something similar, but basically it's just a rigid plastic channel that comes in different lengths, and then you can space it out as needed, and you can see the gentleman installing it right there. Again, not something we see a lot, but you can definitely see where it would be where applications could be for it. This isn't really related to the fastening, but something you want to keep in mind with wet installations in general. Whenever you are going to be going between two separate slabs from a construction joint, you want to put some sort of protection on it. It doesn't have to be anything crazy. Just here they're showing like a polyethylene sleeve that Rao can provide. Again, other manufacturers would have something similar, or you can supply your own, usually at a lower cost. But essentially all you want to do is wrap the pipe where it's coming in and out of the expansion joint to prevent the pipe from rubbing against it over time. The pipe's extremely resilient. The pipe that Rao, for example, uses is PEX A pipe, and most other manufacturers have different levels of pipe available too. But just to be safe since these are going to be installed for 20 plus years, it's good to have a little protection where the pipe is going to be expanding, contracting, and could possibly rub on a concrete edge over time. And here you can see the pipe installed using the first technique we discussed, the nylon ties tied to wire mesh in there. And you can also see on this control joint, they've shown the sleeves added in there. All right, I'm not going to talk too much about the actual layout designs here, but I do want to point out you can use these different patterns to make sure that you are avoiding control joints as much as possible. So if you look at the top, both of these are actually what they call counter spiral designs, where the supply and return follow each other all the way to the inside. Regardless of the technique, though, you want to eliminate as many of the tubes going across the control joint as possible. So if you see on the bottom here, they've basically gone across with the supply and return just one time versus about 6 times on the top. Saves yourself a lot of headaches and a lot of potential failure points at a control joint. Also related, if you're going to be putting saw joints in the slab, you want to make sure to not run your pipe beneath those areas and make sure to keep all that coordinated with the concrete guys so that everyone's on the same page. As soon as the pipe is covered up, if there's going to be any cutting or whatnot going on, make sure it's marked with spray paint as soon as possible, locating the pipes so that nothing gets damaged. Here they're showing the pipe kind of sandwiched between a couple layers of rebar and whatnot. And again, something you want to check with the structural engineer if it's going to be, when you start getting into crazy applications like this, if you have suspended slabs and whatnot, and a slab on grade in a residence, this is not something that's going to come up. Just as I touched on before, the percentage of concrete displaced by standard Railfix tube is 0.8%. So really it's not going to have a structural deterrent to the system. Whenever you're installing radiant, again, the tube is super durable, but you want to be extremely careful to take caution to not damage the tube during the install. If you're going to be running wheelbarrows back and forth, make sure you're at least dropping them on like a piece of plywood or scrap so you're not adding extra stress to the tube. And same with loose metal objects and whatnot. Just keep the tube away from any hazards. Where you can always put a piece of scrap between it and a piece of metal, for example, to keep it from rubbing until the slab is poured. If you're doing a over pour with the concrete, there's going to be some different techniques for installation because you're going to be attaching it to a subfloor. Common, especially if it's a wood subfloor, using these Nylon Talons on the top or a staple here on the bottom is the most common. Here you can see they've stapled it over the vapor barrier, and then what they've shown here is they've added a separate base plate here underneath the standard base plate on your wall to accommodate the overpour. So it's another thing to consider. If you're doing an overpour, you're obviously going to be adding a couple inches to the floor. So this gives you a little sleeper around the edge to nail in any subflooring, or I'm sorry, any flooring over the top of the finished slab. Again, common for installing over wood floors would be a staple gun, a pneumatic staple gun, very common. They have, as you can see here on the right, one specifically set up for radiant installations. Again, this one's from Rao, but all manufacturers would have a similar option. Here's the Nylon Talons. These are very time consuming because you're going to be putting each of them individually by hand, but it certainly is an option. And then here's the Railfix I mentioned earlier for the slab on grade installation. It can also be used on the subfloors. It's more of a pricey option, so we don't see it a lot, but it's definitely certainly available. if it's something that you're interested in. Real quick, I'll stop on this just for 1 second because there was a similar question related to the R value for the insulation. Your minimum R value is going to be a function, in general, is going to be a function of the code. But the best rule of thumb here is for a suspended wood floor is to put a minimum of R5 underneath on the bottom, but it should be 5 times the R value of the floor covering above it. So if you have, wood floor, count your subfloor as well. So you have, 5/8 or 3/4 inch subfloor plus whatever floor covering you're going to be sticking on top of it. If there's an unheated space below, you should go even higher. It should be 10 times the R value. As far as the slab on grade requirements, it's hard to recommend a specific R value because a lot of the radiant, poly insulation materials, the one I'm familiar with is CoverTech, where it's 2 layers of bubble wrap almost with the aluminum barrier in between. Those ones have lower R values, but because they have an aluminum radiant area suspended between with an air gap from the air bubbles, it actually provides a higher insulation value than the R value would suggest. So in terms of what's the minimum required, you should double check with the code requirement in your local jurisdiction. Most of the time it's not required underneath the slab if you're using edge insulation already, so there's no minimum, but depending on the application, there may be a minimum required. If you have a specific application that you have questions about, again, feel free to contact me, or I'll give you my contact info again at the end, but and we can certainly help make sure that the specific code in your area is being followed. I did get another question about using bend supports, and I will touch on those, but you certainly, where the tubing is coming in and out of the slab and going up to the manifold, that is definitely something that you want to utilize. Here they are just topping off the slab with the wet gypsum concrete. One thing with these wet over pour installations, depending on the type of floor covering you're going to be putting on top, this is usually just a residential application, but depending on what you're going to be putting on the top, you may need to install a sleeper to give you something to nail to. So if you're going to be putting in wood floors, you obviously can't, or would prefer not to be driving those into the overpour. Now, a lot of the engineered wood floors these days are floating, so that's not something you would have to accommodate for. But if you're using a traditional nailed down wood floor, something you need to take care of would be installing sleepers before you do the overpour. All right, let me real quick jump over to another presentation here. Sorry, just a sec. Okay. One other overpour installation or technique that has come out recently from Rao, and I'm sure other manufacturers have something similar or on their way to providing something similar, but this one is called Rao Speed or Railfix Speed, and what it is an overpour type application, so it's for a wet install that as we were just discussing, but it allows you to connect to a subfloor without using a fastener specifically. So how the system works is you can see briefly on the top right here, the gentleman's installing a pad that sticks to, and what it happens is you peel off the back and it sticks to the subfloor. So this is typically used when you have an existing concrete slab and it's going to be very hard to fasten a new flooring to it. This allows you to just stick it to it with the adhesive already on the back of it, and then the tubing comes to you with wrapped in what they call hook and loop. It's basically generic Velcro wrapped around the tube, and the tube is simply stuck to the mat that was applied, and then you pour over the top of it. It's a very, very simple, quick and easy install. Saves a lot of manpower, and it saves a lot of installation time. It does come with a significant upfront cost compared to just buying the tube itself and nylon ties. So you are paying for the luxury and the labor savings, but from what we've seen so far, if you have an existing concrete slab installation, this is the best way to install it for sure. Here's one installation that we did recently that you can see. And real quickly, going back, you can see the pipe ends here in the corner. But you peel off the back, you stick the mat to the concrete, and then the tubing gets spaced out over the top. And the little design on the mat gives you a bit of a grid, so you can count off how far to space the pipes and whatnot. So this is just another option that you want to keep in mind for a wet installation. Gives you an option for any, and as I mentioned, it can be used in other situations, but when you have an existing concrete slab and they want to put a topping slab over with radiant in it, this is by far the easiest installation we've seen so far for that. All right, let me jump back over here. All right, so poured installation or wet installation. Keep in mind using insulation underneath. I didn't touch on it too much, but on a suspended slab or on a suspended overpour, you want to make sure that they are putting insulation in the joist space below. If there's a heated zone below, as I mentioned, if there's a non-heated zone, you still want to put a minimum of R5 as we talked about, or 5 times the floor covering above to drive that heat up. It might, if you're on a first floor, you might think, oh, the basement's heated, it's not a big deal, but you really want to supply that insulation so that it's heating that top zone without overheating the basement zone. And then make sure you've selected the fastening or the fastener appropriate for the installation and have the right tools to install that. And then, as always, planning and preparation in those types of installations, especially with thermal mass, you get one chance to pour it pretty much, and otherwise you're going to be chopping it up with a lot of time and effort to repair it. So planning and preparation is first and foremost with a wet installation. I've got a couple other comments here before we keep going. Is Rao speed a vapor barrier? No, the pad, I'm assuming is what you're talking about, but correct me if I'm wrong. The pad portion of the Rao speed installation does not provide a vapor barrier. I can look at the specs if we have time later on, or we can all look at them together to see what the composition of it is, but it's basically just almost like a nylon or felt type material that has adhesive on the back, and you overlay it or overlap it as needed, but it's not intended to go to the edges of the zone and create one like homogeneous barrier or anything. Does tape derate the output was another question I got. If there's tape on the, oh, I see, on the Rao speed, does it lower the output of the tube? I'm assuming is what the question was. Rao does not provide a value for that. I can say from talking to them that the basic answer is no, or it's so small it's not measurable, or you don't need to account for it. Once the concrete is poured over it, it absorbs a little of the moisture from the concrete, but then all of that moisture obviously dries out eventually, and this basically becomes one homogeneous slab. So as it's warming up, it may take, I mean, I guess you'd probably work it back. It'd be a matter of seconds, but it could slow down the slab heating up slightly, but not enough for anyone in the space to notice by any means. All right, we're going to transition to dry installations, which are any installation that does not use a wet thermal mass that dries. Specifically, I'm going to be talking about the joist space installations first, and then we'll be touching on some over-the-floor options as well. So how does it work? You're going to be installing the tube in the joist space below, and then we're going to be trying to drive the heat upwards. There's different techniques to do this that we're going to discuss. The pros to this type of installation are retrofit. That's basically the foremost advantage to it. They also live tier, no structural weight issues, no added moisture. Those two are, I wouldn't say pros. I mean, they're definitely benefits to this type of system, but I would not install this system just because it's saving weight, because in most cases an overpour slab is not going to add enough weight that it would cause any issues, and that would be the preferred installation. This is more, I would say the word to circle here would be retrofit for joist space. The other word you might add would be lower costs, because this does have some cost savings compared to a wet installation, but in general, we reserve or recommend joist space be used in a retrofit, just because, as I mentioned before, you're not going to be able to drive as much heat up through these floors, and it's going to take a little longer for them to recover or provide heat. The installation can be difficult and slow, but that's really dependent on if what all is existing in the joist space below. If you're working around existing piping and whatnot, it can certainly be quite challenging and frustrating. So definitely something to keep in mind. So you can see here they have some minimums for the installation. What they're recommending here is what you want to do where the purple or pinkish kind of zone is on the diagram on the right would be the air gap, and then you'd want to install the insulation preferably foil faced, facing upwards below the air gap but above the space below to drive that heat upwards. This is another cutaway of an actual picture, so it's a little easier to see. They're showing, instead of like bad insulation, just a foil faced bubble wrap type insulation. And again, leave an air gap so that it can help heat that area and then drive it upwards. There's a couple different, or well, there's many different ways you can attach the tubing to the subfloor above in a joist space application. The easiest or the simplest, I guess is the best word for it, would be using a talon or pipe clip or a staple and just connecting the tube directly to the floor. Most manufacturers will have options for different heat transfer panels. This slide from Rao is just showing two of their lighter weight panels. These are nice because they're only 2 and 4 feet long, and they're for an individual stripe of pipe. So depending on how tight, as I mentioned before, the different material, the spaces, you might need to go to this type of installation. But the preferred in the Rao world would be this panel right here, which they're calling Rao plate. Again, other manufacturers are going to have something very similar, probably with a different name, but we're going to be talking about the same material here. So this allows you to run 2 lengths of pipe in each joist base with one aluminum heat transfer plate. They're 8-inch across, so it's basically set up for 16-inch floor joists. I'm sorry, you can use it in any size spacing floor joist, but using it with a 16-inch on-center floor joist will give you 8-inch spacing across the entire floor. So makes it nice and easy. You're only fastening 6 screws in each of these, so it's much faster than if you have to. If I go back really quick to these other panels, you're going to be putting at least 4 screws in each of these, and they're only covering one length of pipe for a couple feet. So this is definitely the Rao panel, or I'm sorry, the Rao plate here is definitely a faster option, and it provides greater heat transfer. So one option there. In terms of installing the Rao plate specifically, you're going to be basically installing them from each length of the in each of the joist base cavities, and then running the tube through each cavity and then back to the manifold. This is a nice option for doing this if they're all going to be in a uniform area like this, running the headers off to the top and then back to the manifold. You are going to be putting a lot of holes in the joists just to get all the pipe ran, so that's going to be something you need to accommodate as well. And again, this is showing the Rao plate panels, but same type of recommendations would apply to any panel system or if you were not using panels at all. Just some additional notes on how to handle the Rao plate specifically. I won't get too involved into this specific product, but basically you're going to be cutting these to length as needed, and you want to make sure to deburr the ends of anything you're using so there's not sharp edges everywhere. Okay, here's a installation so you could take a look. This has obviously been installed before any of the piping, or it's just in an area of the house that does not have very much electrical and piping overhead. As you can see, they're all running Romex here, so they have a little more space. In this area where it's conduit, it could prove to be a little more tricky. So this is the same type of thing except with the smaller panels I touched on. Obviously a lot more to install, but another option nonetheless. Real quick, I want to touch on a couple other dry installation techniques. All right, there's 2 other techniques that are pretty new. Again, these are the Rao names for them. Other manufacturers will have their own, but they're called Rao Panel, which is an aluminum-based panel system, and then Rao Board, which is similar to what you might see like Warm Board or other brands as well, where it's a plywood-based with an aluminum backing. So these both install very similar, so I'm going to touch on the Rao Panel version just to give us a little example here. The Rao board would be the same, it's just a little bit lower cost option and a little less heat transfer. So let me quickly run through this. I'm going to try and speed it up so we're not taking too much longer here, but I do got a little more to get through. So keep the questions coming, but I might have to address some of these at the end. Real quick before I start, since there's a couple of questions here, it's Rao plate. Is it imperative that the Rao plate or whatever plate you're using sits flush to the underside? can it be floating within the 2-inch air gap? I mean, if that's what you're left with, you kind of are stuck with that. Your follow-up here is a lot of nails or screws can penetrate down, so it's hard to get anything flush up against the top. Yeah, that's one of the disadvantages of the aluminum heat transfer panels is you basically have to have access to the subfloor, and it has to be relatively clean. If you have installed, if there's, as you said, if there's flooring installed above where there's nails and whatnot coming down, it might not be the best application, because in order for the heat transfer panels to add any benefit, really, they do need to be up against the bottom of the subfloor snug, so they can transfer as much heat and as evenly as possible into the wood subfloor. One of the main advantages of the heating panels, the aluminum panels, is that they help disperse the heat through the subfloor. They obviously do improve the heat transfer in general, but versus having the tube just stapled to the bottom, where it can kind of create a temperature gradient in certain situations on from the flooring on the top. The aluminum panels really help disperse that, so they do need to be up against the floor. If you weren't going to be able to do that because of nails or whatnot, I would just recommend skipping the panels and doing the tubing directly to the subfloor, because if you start pulling it away from that subfloor, it's just going to lose its effectiveness. There's a couple questions here regarding cost per square foot and labor. To be perfectly honest with you, I don't have great numbers on either of those, but I'll try and touch on those at the end here. And then one other was a question: does the Rouse have a femoral height adhesive? That I can't say for sure, but I don't think so. So I'll have to definitely check with the manufacturer and let you know on that. I can't imagine that it does, but I'm sure it does have some VOCs to it, like most building materials. But that's something that we can address, or that the product itself would address, and I can show you where to find that information too at the end here. All right, so let's go through the Rao panel real quick, and then I'll get back to the estimating and whatnot. All right, so this is the dry panel, one of the dry installations for over the floor. As I'm sure you were aware, the ones we were just touching about were for underneath. This would be the on top version, and a great option, as we just discussed, if the underneath subfloor is too impenetrable, or there's too many nails sticking out or whatnot. So this gets installed directly over an existing floor or subfloor. It's a combination of an aluminum panel that the tube gets placed into, and then some plywood trim pieces to route the tubing around. These panels are 6 inches across, so that they can be spaced either 6 inches on center, or with the plywood accessory pieces with a spacer 8 inches on center. As it says here, best solution for above floor radiant. In a dry application, this is a really fantastic way to add radiant to a space without the thermal mass. So as we mentioned before, I would not install under floor joist space heating just because of the weight. That's something that if weight's really an issue, this is the type of system you would want to look at. This uses a 3/8 inch PEX pipe, and then results in an overall panel thickness. So from below, it adds 5/8 inch to the thickness of the floor. The Rao board system that I mentioned earlier uses a 10 millimeter pipe that they brought over from Europe, and results in a 1/2 inch thick panel. So if that's a consideration, or I'm sorry, if that's a requirement, you would want to go with the Rao board instead of the Rao panel. But in terms of heat transfer, since this uses the aluminum panels, this would be definitely the preferred application. It is very very, very high initial cost because of all the aluminum, but it's a very effective system as well. So as you can see in the top right, it comes in pieces, all individual, so that allows you to customize it to the specific floor space that you're working with. It's a combination of plywood spacers, these return bends with grooves cut into them for the pipe that can be cut to size, and then the aluminum transfer plates itself. I usually recommend that the contractor, if he's able to, provide these furring strips in between. They're just 2" by 5/8 inch thick by however long you need them to be. And if you buy them from the manufacturer, you're going to be paying for plywood. So some tools when you're using these, you just want to make sure to deburr them and then chalk lines and saws as needed with any other installation. I'm going to start going through this just a little faster, sorry. So you just start along one wall, drop them in place as you need them, and keep on going with the pattern based on your layout. You do want to leave a little gap when you're butting them end to end for any expansion and to prevent any noise with the system going forward. And then after you get it all laid out, you simply go back and walk the pipe into the grooves. You may need to hit it with a hammer, or some guys will strap some scrap wood pieces to the bottom of their shoes and walk over it to really get it down, set into the grooves and flush. You can make repair couplings, or I'm sorry, repairs if needed, if it gets cut during construction or whatnot. Simply just cut out the piece in question and connect it with an Everlock coupling here. Now this panel can get used with several different over-the-top floorings here. So as you can see, 1 through 6, plenty of different options here. Number 6 there, I'm not going to touch on concrete slabs because we would definitely recommend the Rao speed for that. But if you were going to keep it, if you weren't going to be putting another a thermal mass over the top, you could use this with concrete. You just have to worry about anchoring it into the concrete, which can be very, very time consuming with tap cons and whatnot. So with a nail down plywood or wood flooring, you definitely need to do 8-foot spacing so that you have the nailers for the so you have a place to nail the wood floor. Otherwise, you're going to be dealing with going through aluminum panels, which would not work very well. Again, yeah, you can do the 6-inch spacing if you want, but you're going to need to deal with the aluminum panels there. If you're using a floating floor, that would not be an issue. Make sure you're going through both to get into the subfloor. And here it is with the hardwood installed directly by the panels. You also want to make sure that you're going perpendicular to the flooring. If you are going over concrete, or if you're going to be using a floating floor, you do need to anchor the plates to the floor. If you're doing a nail down floor, they can float. You would just nail the wood down. But if you're going to be using a floating floor, or you're going to be connecting to concrete, you need to anchor the aluminum panels to the floor. And then here's a floating floor where they have an underlayment as well. That will not bother the panel system. You can use an underlayment, or you can use whatever the manufacturer recommends. It's not going to bother the flooring system, which is the nice thing about this install. Here they're using a glue down floor. Again, does not matter. Apply it straight to the flooring. You want to avoid putting the glue on the tubes. It's okay if some gets on there, but just for heat transfer recommendation, for heat transfer purposes, sorry, you want to avoid it getting on the pipes. Here's just another install photo showing that you can get into different areas. Now, as far as routing the tails back to the manifolds, that's something tricky with these overfloor systems that you have to be cognizant about, with the underfloor systems too. But with these, since the piping is run on all these prefix channels, you're going to have to either create your own routing in certain areas or leave some gaps. So as you can see here, they've kind of brought all the tubing into one area, which is going to be funky to put the flooring over. So you kind of want to avoid this. It can give you a warm spot. Here's a better example. This, they've gone and routed in actual pipe routing. You don't necessarily need to get that involved, but that definitely results in a very nice finished product. You could, just cut pieces of plywood to kind of fit in the tubing as much as possible. Here is a great option if you want to bring the tubing down through the subfloor, and then you can route your tails through the joist space. As you can see here, they've dropped them all down and then gathered it below to run to the manifolds, which you could either mount the manifold down below or bring it back up through the flooring in a different location to the manifold. This is just the technique for doing as much. You want to cut that on about a 45-degree angle. Make sure you clean up all of the dust so it's not anything that can create issues or noise later, and then drop the tube down through there. All right, real quick, we'll switch over and talk about carpet or vinyl. When you do carpet and vinyl, you're going to need to put a piece of plywood over the top of this system. You don't need to, as you can see on step number 2 here, it says, oh sorry, let me let the, can everyone see the screen okay? Looks like it's trying to load up here. Okay, sorry. So when you're doing a carpet installation or vinyl floors, in order to get a flat, even surface, you're going to need to put a thin layer of plywood above the panel system and below the flooring. So they're showing here an 1/8 inch thick thin plywood underlayment. And so you're going to be fastening that plywood down, so you don't necessarily need to put you don't need to secure the aluminum panels. I'm sorry, they'll get secured once the floor is attached. As you can see here, they've got the little. They didn't show a carpet pad or anything, but there's the 1/8 inch plywood and then the carpet over the top. And once you fasten the plywood to the top, as I mentioned before, mark where the tubing is on the either the subfloor or at the joist at the end of the, the header at the end of the wall, so that you can secure appropriately. And this is just a carpet installation going down. With tile, you could theoretically do thin set directly on top of the panel itself. If you do that, you do want to secure the panels down. Otherwise, if you're going to be putting down cement board, you do not need to secure the panels. You would just secure the cement board through the system down into the subfloor. So this, as just mentioned there, this has a 1/4 inch mortar board directly over the Rao panel. And as you can see here, there's no plywood strip, so this is 6 inch on center installation, and then the tile is placed on thin set over the mortar board. Here it's showing them directly beneath the shower. No problems there. You can install this, as I'll point out shortly, on walls, ceilings, floors, wherever. Another good application for this system. In regards to bathrooms, with this tube or any tube, you want to avoid getting too close to the wax ring for a toilet. Keep it about 10 to 18 inches away from any toilets. Okay. This is just a quick reference on going over existing concrete slabs. Depending on whatever floor covering you use, going backwards, you just reference that installation type. Just you'd have to secure with anchors into the concrete. So make sure you test that out depending on what type of gun you're using to secure those. Test it out with a panel in a undisclosed, in a private location that no one's going to see, to make sure that they're securing, that you get the gun dialed into the right power to get them shot flush. And where you can, if you're going over existing concrete, where you can, we would recommend Rao speed with a topping slab or a wet overpour, as it makes the installation much more quick and less painful. Real quickly on corners, make sure you're using a piece of the return bends cut. You don't want to go with a sharp corner, and then just make sure all of your edges you're deburring or sanding to make sure that there's nothing tearing into the pipe long term. As I mentioned, the pipe's very resilient, but you do want to make sure that nothing's going to be slowly rubbing on it over time, because these things will be around for 20 plus years. The Rao Panel or Rao board are great systems because they can be adapted to any shape room, just by, it's like Tetris basically. You can use them in any configuration. As I mentioned, a great application for these is walls, specifically in a shower or behind mirrors and whatnot. As you can see here, this is going in behind a shower, just up on the wall, and then they would just put the green board over the top. Here's another great application. As I mentioned, you have to be cognizant of how much output you can get out of a floor. So perimeter zones that might require more, you can certainly use other types of heating to supplement it, like baseboard or whatnot, but one option, if you have the space, would be to also run tubing underneath or in the wall beneath the windows, or in other areas to help offset the heating load without adding different types of heat. Another application. All right, let me quickly get back to this. Number 2. Okay, real quick, I'll go through distribution manifold locations real quickly. There's two main aspects that you want to look at. You can either have one large central manifold or several smaller ones, just depending on the zone. Manifolds are available from 2 up to 12 zones. We typically recommend keeping them between 7 and 8 at the most, just because you're going to be bringing a lot of supply and returns to one area. The amount of tubes you need will be dependent on how long your loops are and how big your area is. I will give you some general rules of thumb at the end here, but typically your loop length is going to be between 200 and 300 feet, sometimes up to 400, depending on the pipe size you use and, again, how big the area is. For a residential circuit, you're typically going to be around 250 to 300. Commercial with larger pipe can get go bigger. But in terms of selecting a location for your manifold, we can definitely do it like 2 different ways, as I mentioned. One large one or several small ones. here you can see just how the manifolds are set up in general. For any manifold installation, you want to use the supply and return bends at the bottom here, anywhere the tubing is coming out of the slab. It also gives you, provides a nice, since it's bending at 90 degrees, you don't have to worry about the tube pulling out of place while it's in the slab, and then it makes it look nice going up to the manifold as well. As you can see, a couple of these are shown in manifold cabinets, which most manufacturers offer. The one on the right here has the mixing station built in, which is nice. But you can, as shown in the middle, you can mount them yourselves on some unistrut, or they can be mounted in an access panel. Traditionally in residences, we see them installed in the wall cavity, and then either access panel or even a return air grate is placed over it to serve as an access panel. It's a very low cost way of doing it versus buying manifold cabinets. Or if you stick them in the joist space in the below, it's another great way to hide them as well. But as I was mentioning, 2 versus 1 in as far as manifold locations in a residence. Here we're showing 2, one on each side of the house, and then this is showing 1 here in the middle. And so what you're basically have to worry about is routing all of the supply and returns back to the main manifold. So here they've shown 1 manifold supplying the whole house, but as you can see in the left portion of this photo, all of the tubing is getting very close together as it gets to the manifold. So what this can kind of create is a very hot spot, because all of the heating is going to be coming through that one location. So you have to be careful about creating too big of manifold where too many supply and returns are going to be pulling in. We're at about 1 hour and 15 minutes already, so I know some of you guys are going to have to be leaving for different things. This will be recorded and posted on our website, so if you do need to leave a little early, I will make sure to get that to you, the link to you, or if you have specific questions I haven't answered yet, throw them in the question box, and I'll be sure to try and answer those as well. All right, back to this. Let me get into the full screen. Here we go. So this is just an overhead view, obviously, showing the different loops. And what they've done is basically put 1 manifold per classroom. Obviously, that's very common. It allows you, and here's another thing where they've split it into 2. It's very common to do 1 manifold per zone where the zone allows. Obviously, if it gets to a certain square footage, like this zone, they've split in 2 because it was 4,500 square feet. The amount of manifold locations are going to be determined obviously by how many circuits you have, but also by how much space the architect is giving you. To some degree, you're going to have to tell them how much space you need, but they're also going to try and limit how much space you have. So that is another consideration, but as I've mentioned, ideally you want to keep them below like 7 or 8 manifolds. I'm sorry, 7 or 8 circuits per manifold. All right, so the step-by-step installation process I'm going to gloss over very quickly. Every manufacturer is going to provide you with a system installation guide that gives you the details. Basically, it's going to be a combination of selecting your installation technique, making sure you have the proper materials, and then just cranking it out. But let's go through this real quick. So here they're installing the actual tube with a tie-down application. The first thing to do is mount your manifold. So you have some place to route the pipe to and from. It can be a temporary if needed. As you can see here, they've simply attached it to a piece of 2x6 while they get the rest of it set up. You're going to route the tube through the pipe bends, secure the pipe to the floor, and then route it up to the manifolds and connect it with the manifold connectors, which will be dependent on the pipe size itself. Here they made a station out of some unistrut to hold it temporarily, which is a great option as well. Okay, more temporary manifold structures. One thing I will point out real quick, the reason you do want to have the manifold installed, whether temporary or permanently, before you start installing the tube, because in order to test the tubing and the flooring for leaks, you do want to have it brought to the manifold so you can isolate it. All right. Here they're just showing they've had the manifold routed to a different area, as I touched on before. Manifold is not going to care what orientation it's mounted in. They do have air vents with them built into them, or if depending on the orientation, you may need to add some in the piping in the supply and return to the manifold. But as far as, upwards, downwards, what type of wall or ceiling it's located on, the manifold's not going to care. Here they're pointing out that this isn't the greatest example because it's not lined up properly, but this is still a pretty decent manifold installation. They've routed them all up through the flooring, and they are bunched to the left a little bit, but depending on what's existing, you might not always have other options. Ideally, yes, you do want to have them all nicely lined up. The better your manifold station looks, the better, the more professional the job looks, of course. Here's just two nice pictures of an install where they've used some unistrut to line and cushion clamps to line up all of the pipe ends nicely. As I mentioned, all the pipe gets secured to the manifolds with the bushing size for the pipe size. If you're going to be installing longer loops or using larger loops of pipe, 1,000+ feet, uncoilers are certainly helpful. We try and size the pipe size, or I'm sorry, the overall length of pipe based on the loop lengths. So for example, in residential installs, we use a lot of 300-foot loop lengths for circuits, so we sell the pipe in 300-foot loops, which eliminates the necessity for an uncoiler. Not that it wouldn't be helpful, but it makes it a lot easier to handle than when you get into the longer 1,000-foot plus loops. An uncoiler can definitely be handy, I should say. Sorry. We have one of these for rent in our Melrose Park warehouse if you guys ever need it, or you can purchase them if you're going to be doing several installs. Okay, speed up just a little bit. As I mentioned before, you want to be careful with saw cuts or expansion joints to note wherever those are. Make sure the pipe is secured. If you're going to be doing a saw cut, make sure all the pipe in that area is secured to the down below it correctly. As I mentioned, avoid toilet gaskets or any other appliance that would be sensitive to heat. They've also mentioned here, if you know where cabinets are going to be and they're going to be permanent, no reason to put any piping underneath there. It's just going to be wasted heat. Expansion joint covering, protective sleeving, we've already touched on that, so I'll skip through here. If you ever have to bury a fitting, make sure that the fitting is approved for it. Rao uses the Everlock, or I think the generic name for it is F2080 compression fitting, but is it acceptable for being buried in the tube, or I'm sorry, in a slab, or in the ground, which is very important. You just apply the coupling and then wrap it in either electrical tape or another waterproof tape, and you can go ahead and pour over it if needed. If you have a break in the slab and have to cut up part of the slab, this is the coupling you'd want to use to repair it as well. All right. As far as testing, air testing is permitted by Rao and most other manufacturers. It's a great way to do it, especially if it's in freezing temperatures. You want to test it ahead of time, of course, and then you also want to keep it pressurized during the pour if you're doing a wet application. It mentions real quickly here, just after everything's set, you do want to make sure that the air vents are working. You do not want to have this installed or open while you're doing the testing, obviously. So make sure you go back and open those after all the testing has been done, and bleed out any of the air left in the system. This is showing how you can flush each of the individual loops if needed, or flush the system as a whole, or fill the system with the drain valves that they supply. You can isolate each of the loops in a Rao manifold from the supply and return as needed, and then you can also use those same functions to balance it with the flow gauges that are provided with the manifolds. I should have pointed this out up front, but I've been speaking specifically about Rao's Pro Balance Manifolds, which are pre-assembled manifold, supply and return header, brackets, air vents, isolation, etc. You can certainly create these yourselves using copper piping and fittings if you want. Just the pre-manufactured manifolds, whether the Pro Balance ones from Rao or another manufacturer, are the easiest way to go as far as time and labor, because they're already set up for the specific amount of circuits and have all the accessories you would like to include anyway. Just some precautionary stuff. Cover all manifolds and anything sensitive when you're doing a wet install to protect it from the concrete. Get through these a little faster. As I mentioned before, if you're going to be pulling in wheelbarrows and whatnot, make sure all that's protected from the tube. All right. And then after you get it all installed, whatnot, you can come back and balance out the manifolds. As you can see in this picture, this is the Pro Balance manifold I was just mentioning and that you've seen several pictures of. It comes with a little key underneath the blue caps on the return here. You can stick the key in and use that to balance the flow, and then it'll be displayed on the flow gauge up at the top there. These are a couple of just what not to do pictures. Make sure the manifold's level, make sure it's organized. You want to make sure that your piping is routed in an organized manner, so if you ever have to go back and find out and isolate a loop based on a location or whatnot, it's easy to do without going through a whole lot of testing. Manifolds can be installed in any locations, as I mentioned, and any orientation. So do not add 50 feet of extra pipe by doing this. Just simply turn your manifold upside down. And maybe don't do this. Always pay attention to this piping spacing. You do not want a bunch of, even though it's getting covered in a radiant slab a lot of times, a concrete slab, you still want the piping to be uniform as possible so that it doesn't create any like cold and hot spots. Also, you ideally want to avoid connections within the tube, or I'm sorry, within the slab, just because they could create a point of failure. As I mentioned, there are certain manifold fittings, or I'm sorry, PEX fittings that are approved for concrete slabs. So if you have to use one of those. But even in that case, only where necessary. Don't avoid it if possible. All right, let me quickly go to estimating, and we'll buzz through this real quick, and I'll give you some rules of thumb, and we'll be out of here. Okay. So for estimating, we're going to need to know the pipe size, quantity, and then get all the accessories associated with that specific install. So let's get through here real quick. The pipe sizing is going to have to do with your flow and the installation type and how long your circuits are. There's different sizes available from 3/8 up to 1 inch. There's also more from 1 inch upwards that we commonly use for what they call interconnecting pipe. So you can use Rao piping to extend from your manifolds to other locations or for other types of piping in your heating system. There are other sets of piping available for domestic, but this piping that we've been speaking of, PEX A, Railfix, is specifically for heating only. Different pipe sizes, as I mentioned. All manufacturers are going to have basically the same options here. So I'm going to keep with the Rao material because that's what we have. But again, remember that this is pretty much applicable to everyone. So here they're talking about the different aspects that can affect your piping quantities, the type, installation technique, perimeter, occupied areas, spacing, etc. We've touched on most of this, so I'm going to try and buzz through it. The shape of the building, if you want to do tighter spacing around the perimeter, all of this is going to affect the amount of tubing you're going to use. But, and we'll do a couple estimations here, it's not always going to have a huge implication on your final cost. So in terms of estimating the pipe, once you have the area, you need to know the pipe to area ratio based on your install, and that's ultimately about the spacing. So the formula for the spacing is basically 12 inches divided by your spacing, and then you multiply that by the floor area. And so that'll give you specific examples down here. So if you're working with 12-inch spacing, it's 1 foot of pipe per square foot. So if you have 500 square feet, you're looking at 500 feet of pipe. If you go down, if you tighten up the spacing, you're going to have a lot more piping per square foot, as you can see here. The common spacing that we see is almost always 12-inch spacing. If you're going to be doing snow melting, it's more commonly around 9 inches. And we see 6-inch occasionally. That's usually with cooling, though. As I mentioned, you can go a little tighter on perimeter, along the perimeter. So you may want to, tighten the spacing to 6 or 8 inches for 1 or 2 lines right by the perimeter, and then go back to 12-inch spacing. That's certainly something you can accommodate as well. So just for an example, this is a 1,600 square foot warehouse, 40 by 40. First thing you want to do is calculate the area. Let me do this first a little more in depth just to give you, so we can compare the two. But they're going to show, so we're going to do 8-inch spacing around the perimeter for a couple feet, 3 feet, and then 12-inch through the rest of it. So if we apply first we find out that we have, of the 1,600 square feet, 1,450 are actual floor space and not walls and other areas that we can't install pipe. And then we're going to do 440 square foot of that area is 8-inch spacing, which would require 606 feet of pipe. And then the remainder of that area is 12-inch spacing, which would be 10,051. So we'd have 1,657 feet of pipe. Now, the quick way to do this would basically just be to say we have 1,600 square feet times they're estimating our spacing requirement of 1.1 instead of 12 just to be safe. That gives you 1,760 square feet of pipe. That's just 6% over the more in-depth calculation. So in terms of spacing, even if you're going to be doing a perimeter zone like this, you're really not going to be, by going through and calculating it all individually, you're not going to be saving yourself very much material or time. I'm sorry, you're not going to be saving yourself material, but you're going to be saving yourself a lot of time. So this is just a second example, 1,200 or 2,500 square foot on grade residentially. If you're going to be doing a thin pour, which they're suggesting they are here, you multiply by 1.3, and that would give you 3,175 square feet of pipe. The next portion, after you have the pipe figured out, would be to calculate your fasteners. Nylon ties, I mentioned before, and most other fasteners, you want to place every 2 to 3 feet or space them out a little more. So we usually figure that they're going to be going at every 2 feet, which means you're just dividing the amount of feet of pipe you have by 2, and then that'll tell you how many either nylon ties or foam clips or staples, etc. Okay, Railfix and other pieces like that will, if you go to their product page, will show you how to do the spacing. This is saying each piece is 2 meters long, and you're estimating 1 piece per every 18 to 20 square feet. So it'll tell you exactly how many you need, and I'll show you a quick example of that in a second. The manifolds will be determined by the circuit. So how do you determine how many circuits you have? Well, as I mentioned, typically for radiant in a residence, for example, we'd be around 250 to 300 square feet. So it's simply a function of dividing out the amount of square feet or the amount of feet of pipe you have into manageable circuit lengths. One consideration for that is depending on how far you have to travel from your manifold could determine how long your loop length can be. So if you're trying to reach another part of the house that's more than, like, let's say 150 feet away, your loops are only, and your loop's only 300, you're going to spend 150 feet to get out to the end of that zone and then 150 to get back. So your manifold manifolds and the number of circuits could be determined by how far away you are from the manifold location, or the desired manifold location, I should say. All right, there's different manifolds based on flow. I won't get too much into that. As you're selecting those, the manufacturer or the supplier will help you identify which one's appropriate there. Again, in terms of manifolds, I mentioned before, this is getting a little duplicated, but based on one central manifold versus several smaller manifolds, it's going to reduce the length of the pipe that you need to get to certain areas of the house, and could also reduce your overall tube requirement if you go with smaller manifolds, but then you are purchasing more manifolds. So they will have in general, more manifolds will have a slightly higher material costs and a lower installed cost, if that makes sense. So I'll touch base on these again in a few minutes, but different maximums, if you will, for loop length. You really don't want to go over 330 feet for ½ inch, which is the most common for residential installs. You can go a little further with bigger pipe if needed. All right, so going back to our example, 1,600 square foot slab on grade, we had 1,760 feet of pipe, and if we divide that by 330, we're going to need at least 6 circuits. All right, and then manifold connectors will be based on your pipe size and a function of the manifold that you're using. Again, this is sold by the same manufacturer as your manifold to make a quick connection. If you're using a copper manifold that you built yourself, you would just need to get a PEX to copper adapter. Also, don't forget the PVC bend guides that we used at the bottom there. We've touched on those a couple times. Those you're going to need one per supply and return or two per circuit. This is just going back to our manifolds. Okay. Now, we've touched on a couple different systems that use quite a bit more materials, specifically the dry installations, the Rao panel and the Rao board, or the Rao speed, which is for going over existing concrete for a wet panel. All of these can be estimated using Rayhau's material estimators, and I will show you that just a second. But for the Rao panel material for specifically, you're going to have the three different pieces, and you're going to need to figure out how many of each that we need. I'm going to skip this because I'm going to show you another way to look it up. But basically, the material estimator will give you the amount of square feet for each of the different pieces, and you apply the different multipliers they give to give you the number of pieces. And let me buzz through here real quick. Yeah, these are all the same deal. Quickly go back to this to wrap up. All right, so to estimate these, you can get into Rayhau's material estimating guides on their website. So we're going to go to that real quick. All right, once you're on Rayhau's website, if you go to the top, they have the Resource Center link, so you can click on that. And then if you scroll down slightly, you can go to the web apps and go to Radiant Material Estimator. And it's going to ask you for your information, but once you get through here, it'll bring up a screen like this. And depending on what type of installation you're doing, you can click it across the top here. So we'll go to Rao Panel since we did a lot of that earlier. And you can you want to pick which of the areas, if you're using 6-inch spacing or 8-inch spacing. So we'll just say it's 8-inch spacing, and we'll say it's a 1,200 square foot area. And as you can see, it'll pop up down here, and it'll show you how much pipe you need and the part numbers for that. It'll show you the Rao panel pieces, the plywood return pieces, and then the furring strip pieces. And it shows you the part numbers, how many per box, etc. So if you have this, you can print it out, hand it to your supplier, and they can print it up for you, and you're ready to go. And if you go to the top here, it's not just for the fancy pieces that we talked about, Rao panel, Rao speed. You can do the different plates. You can do any overpour or slab installation and select the fastener that you like. So I'm going to go over to slab here, and let's say we're doing Raotac 3D foam staples. We're using 1/2-inch pipe with 12-inch centers, and we're heating 1,500 square feet. And there we go. We need a box, 750 foam staples, and 1,500 feet of pipe. And you'll also see under here, it'll say estimate 5 circuits based on a typical 330-foot circuit. So those are really great tools to help you analyze different options, different installation techniques. Let me go back to this real quick to finish up. Oops, sorry, I'm in the wrong one here. Okay, so as I was just alluding to, some different starting points. For radiant heating in a slab under 2,000 square feet, we would recommend half-inch piping, 12-inch centers, and 250 to 300-foot loops. If you go any larger than that, we would probably recommend going to 5/8 inch pipe or just smaller manifolds. So yeah, I should say revise that. So any zone, any individual zone above 2,000 square feet should definitely be looking at a larger pipe size, but any zone under 2,000 square feet, that's going to, 2,000 square feet is basically 7 zones, or 7 circuits, I'm sorry, at 300-foot length. So again, going any higher than that, you would either want to do a second manifold in the same area, or switch to 5/8 inch or another larger PEX size. And then, as you can see, some different applications here. Snowmobile here at the bottom is, yeah, so much touch here on the bottom, but that's a whole another separate webinar, as there's some different application considerations there. Just a quick finish up overview. When you're doing for the radiant, you got to make sure you have your pipe manifolds, manifold connectors, the pipe bends, and the fasteners. Make sure you're addressing manifold enclosures if necessary, either whether it's a supplier provided cabinet or you're providing your own access panels, something to keep in mind when you're doing your total costs. Insulation, make sure you're either providing insulation or the general contractor or concrete contractor is providing it. It's important to make sure who's getting charged with that task there. Heating cooling source we touched on. In relation to that expansion system, glycol feeders if you're doing a glycol system, expansion tanks, etc. We didn't get too much into controls at all, or circulation, but you're also going to need to define pumps and whatnot for each zone, or zone valves for each zone and whatnot. In addition to myself, again, my name's Louis Mino there at the bottom. Bill Bailey and Bill Shannell are both product managers for our different hydronic parts and equipment lines. So they are always available for reference as well. And their numbers and emails are shown there, or you can reach me in the office as well. Both Bill Bailey and Bill Shannell are happy to either meet with you guys directly, talk to you on the phone, meet with you in your office or on a job site for a specific project. If you guys want us to do takeoffs for different projects, we are certainly able to help you with that as well. You can contact any of the 3 of us for any of those techniques. And that's going to wrap us up finally. I'm going to quickly go through some questions here. It looks like some of these might have got answered at the end, but I will address some of these now. So let's see. All right, question. If you have electrical outlets installed in the floor, Do the aluminum Rao Panel panels need to be grounded? That I cannot say for sure, although the second part of your question, does the floor outlet need to be GFI rated? I would assume that if you're going to be putting radiant flooring in, that they're going to require it to be GFI rated, the electrical code would, but I can't say that for sure. That's something you'd want to check with electrical code. I can check into that and let you know. That was Carl. I'll shoot you an email on that. But as far as I'm aware, if the aluminum is touching the box, it would be grounded anyways. If it's close, I don't know if it would have to be grounded. I'll have to double check that. Can you show a preferred installation method for snow brick pavers? Lon, I'll shoot you something on that because I'm going to need a diagram to show you, which I don't have handy at the moment. We do have another snowmelt. We do have another webinar, I'm sorry, was for snowmelt later in the year. And if you want to reference that, it is something that we have recorded as well, so it can be found on our website. But we'll touch base on via email. I can make, there's another question about the slides being available. Most of this is available, or parts and pieces of that I used are from Rao that I pulled from presentations that were specific to the different topics we were talking about. So I was referencing, a Rao panel presentation or whatnot. So based on whatever technique you're looking for, I would first try the Rao website that I referenced. And let me real quickly go back to that. If you go to just rayhow.com, back to where we were, and click on Resource Center again. Under Downloads by Product, you can go to Heating and Cooling, and it'll pull up a little search center. You can pick exactly what you want to search for, but for example, if I put in like Railfix speed, it would come up with all of the literature related to, installation guide, cut sheets for each of the pieces, flyers that you can use with your customers, all kinds of things. One thing you do have to be careful about with searching for the literature is that Rao is an international company, so you do need to go in once in a while and look at the document and make sure that it's English units versus metric. Okay, I think that got most of them. There's a couple more questions, but it was people that have left, so, and they're a little more personalized, so I'm gonna I'll try and address those with you guys individually. I did not touch on labor rates very well, or at all basically, or labor related to the different material or the install types, and that's kind of why, actually, because depending on how you're installing it, it can be very different. If you have a specific application question, we can try and help you estimate approximately, labor in talking with you specifically, but it's hard to do a general number or hourly sum based on that would apply to everything. Same goes for estimating materials as far as, is there a cost per square foot number for concrete install, or depending on the install, it can vary so much based on manifold location, number of manifold locations, each individual based on the shape of the outline, everything. It's very hard to do a per square foot number, and that can be a problem when it comes to customers and talking with general contractors and whatnot as well. So the Rayhouse tried to make it as easy as possible to estimate each individual job, as I showed you with the website, and TEC is certainly here to help you with those as well. where we can. So feel free to come to us if you're ever unsure, but I would avoid the per square foot numbers as much as possible because they're just not gonna be applicable to all situations. Unless you guys have any other questions, I'm going to go ahead and wrap this up. I apologize for running so late with you guys, but we feel like we covered quite a bit. So if you do have any questions that have come up, let me put my info back up here, and Bill Bailey and Bill Shannels as well. Feel free to contact any of us at any time, and we can either answer questions about this presentation or about a specific job you have or a specific installation. Again, my name's Louis Mino, and thank you all for your time. I really appreciate you listening in.